Continuing with P7, more on equations, this video is going to discuss rational equations and solving an equation or a formula for a variable. Rational equations are equations involving rational expressions, which we discussed in P6. We want to solve the following equation: 3 over x plus 6 plus 1 over x minus 2 equals 4 over x squared plus 4x minus 12. When you see a problem like this, notice that these two denominators on the left are linear. However, this term on the right is quadratic. So let's see if we can factor the denominator on the right first. I'm going to leave the left-hand side alone, so 3 over x plus 6 plus 1 over x minus 2. We'll notice that we can actually factor it into the product of the two denominators that are on the left. So we're going to go ahead and do that. 4 over x plus 6 times x minus 2. Now, one thing we want to note is that after solving this equation, we know we want x equals a number or more than one number. But we also need to note that x cannot be minus 6 and nor can x be 2. So when we get to an answer, if we get x equals minus 6 or x equals 2, we will not have, that will not be a part of the solution set. So let's take this equation that's a bit simplified, and what we're going to do is we're going to multiply by the LCD. The LCD for this expression is going to be x plus 6 times x minus 2. We're going to use that LCD in that we're going to multiply both sides of the equation by it. So x plus 6 times x minus 2 times the left side. We're also going to multiply the LCD on the right-hand side. So I need to move my restrictions. We're going to hang on to the restrictions up here. So x is not equal to 6, nor is x equal to 2. Then here we're going to multiply by x plus 6 times x minus 2. We notice right off the bat that on the right hand side everything cancels out. So the denominator of x plus 6 times x minus 2 cancels with x plus 6 times x minus 2. Right hand side is going to take a little more work for us though. When we distribute x plus 6 times x minus 2 onto the first term, we get 3 over x plus 6 times x plus 6 times x minus 2. Same thing for 1 over x minus 2, x plus 6 times x minus 2. In this expression, the x plus 6 on the bottom cancels with the x plus 6 on the top, leaving us with 3 times x minus 2. Second term, the x minus 2's cancel, leaving us with 1 times x plus 6, still equal to 4. Turns out that in this example, what happens is we end up back in a linear equation, which we already know how to solve. So we'll distribute the 3 in. 3x minus 6 plus x plus 6 equals 4. 4x equals 4. 4x equals 1. Find the solution set for the following equation. 1 over x minus 3 minus 2 over x plus 1 equals 8 over x squared minus 2x. I forgot to mention something from the previous slide. We ended up with x equals 1 as our solution. We definitely should be checking this to make sure that it works, and we should also be checking it to make sure that it wasn't either of the restrictions that we had. So 1 is not 6 or 2, and that should be a negative 6, and we're good. So like we did in the last one, we want to try and factor the denominators as much as possible. The left side has linear terms, so those are not factorable. The right hand side again, we're going to notice, and this is sometimes the case, that it factors into the product of the left side, x minus 3 times x plus 1. Now our LCD for this is x minus 3 times x plus 1. Multiply both sides of the expression by the LCD. X minus 3 times x plus 1, x minus 3 times x plus 1. The right hand side, the denominator and the LCD cancel, leaving us with 8. On the left hand side, the x plus 3 is going to end up canceling, so I'm going to be left with x plus 1 minus 2 times x minus 3. I did this a little quick. Now, if you're unsure what happens, go ahead and distribute the LCD into the parentheses like we did on the previous slide, and it should be clear. One thing I forgot to do here is we need to be sure that x is not equal to 3 or minus 1. So we need to put those restrictions on our domain. Let's finish solving this linear example. X plus 1 minus 2x plus 6 equals 8. Minus x plus 7 equals 8. X equals what? Minus 1. Okay. Now again, look back to your instructions and make sure you answered the question properly. This one asks us to find the solution set for the following equation. So we need to conclude with the solution set for x is minus 1. Good. Next topic for this video is solving a formula for one of its variables. So here's a formula, S equals P plus PRT. Each of these S, P, R, and T are variables. We wanted to do two different things. We want to solve this equation for P, and we also want to solve it for T. First, let's solve for P. So I'm noticing on the right hand side that each of these terms has a P in common. So I'm going to factor that out. So P, and when I factor it out, I get 1 plus RT. And again, we're solving for P, so we want P equals something. The only other thing I need to do is divide both sides of this expression by 1 plus RT. 1 plus RT. These two cancel, and we get P equals S over 1 plus RT. For the second part of our work, we want to be solving for T. So we want T equals some stuff, not involving T's. I'm only seeing one T in this equation, so let's get it by itself on one side, meaning, let me rewrite the equation, S equals P plus PRT. We want to isolate the T, so I'm going to subtract P from both sides, leaving me with PRT equals S minus P. Last step, divide both sides by PR. So T equals, looks like S minus P over PR. Still solving a formula for a variable. We want to find the solution set for f2, given that f2 satisfies the following equation. So we have f equals f1 times f2 divided by f1 plus f2. So in the end, again, when we say find the solution set for f2, first thing we want to do is solve this equation for f2, and then we'll say what the solution set is. So I want f2 equals some stuff, not involving f2's. This one is not so clear to see what to do, but the first thing I want to do is I want to multiply both sides by f1 plus f2. I'm really just trying to get that f2 out of the denominator because that's an obstruction for us. When I do that, these two cancel, leaving me with f1 F2 equals F1 plus F2 times F, and I've just reversed sides. Now I'm going to distribute the F on the right hand side, so F1, F2 equals F1F plus F2F. Now I'm trying to gather all my F2s together, so I'm going to want to subtract F2F from both sides. This isn't the only way to solve this problem, but when I do that, I get F1, F2 minus F2F equals F1F. Now I can factor out an F2, so I get F2 times F1 minus F equals F1F. And last step is divide both sides by F1 minus F, yielding F2 equals F1F over F1 minus F. Again, we're asked for the solution set for F2, so in conclusion I need to say the, cordon off some area here, the solution set for F2 is, now there's no numbers here, but it's perfectly fine to say F1F over F1 minus F. Last problem I want to show you is a challenge. So I'm not going to solve this problem for you, but try to solve the following van der Waals equation for any and all of the variables. Van der Waals equation is an extension of Puvner, the ideal gas law.